but I want to tell you a little bit about the title, Selective, because actually bees do have selections of things. They prefer certain kinds of flowers and not others, and we can take advantage of that. The screen stays on. So Albie's telling me to move faster. So I'm going to start with an outline and give you some characteristics of native bees, maybe things that you didn't know about. I'm going to talk about our bee flower work, and I emphasize bees and flowers. This is what we really specialize on, the relationships. And then a statewide survey that we've conducted throughout the state of California, all the way from Redding all the way down to Palm Desert. And then how you transition into Berkeley. So we'll be talking about that. Some of these things you've already heard about, but I'll mention them again. We have about 4,000 species in the United States. You heard earlier about 3,500. Actually, it's about 560 names. That's the reason why we have 4,000. We have 1,600 roughly in California, and about 20,000 worldwide, just in case you're wondering the worldwide picture. You've already heard a lot of this information, so I'm not going to repeat this about the importance of bees. We're also interested in the economic aspects of the research that we do, so we have to tie in with the economists that we're beginning to work on, and business people as well. But I want to get right into talking to you about the huge amount of variation that exists with wild bees or native bees. And you may or may not appreciate that until you actually watch it. You realize how different they are. Not only do they look different, but they have different lifestyles. And they also have different seasonalities. They also have different preferences for plants. This is where the selectivity comes in. Each bee has its own story. This is really important. So we have years and years of work to sort out all these stories. We can group some of these stories together, but for the most part, a lot of bees have different things that they do. Just think about bumblebees. Just think about carpenter bees. Just think about some of the smaller bees. They all have different stories. You've already heard the next slide, which has to do with the fact that California bees and California flowers have co-evolved over a long period of time. These are just some of the products that have happened. We take advantage of that now. We look at them. This plays a great role in what I have to tell you later, so keep that in mind. This is some of the incredible diversity that we have in bees. And the photographer here is Robin Cobell. He's part of our group in Berkeley. And the person who identifies our bees is Robin Thorpe from UC Davis. So we have a team of people that have different specialties. You know what the bee is in the upper left corner? You've seen it. Oh, that's really good. It's called the ultra-green sweat bee. And it's a group of bees that are in the family Halictidae. We actually gave it the name, the ultra-green sweat bee. It didn't have a really good common name. The name Agapostrophe texanus is not something you can pass on to people. And a lot of these bees don't have common names. I mean, it's like birds have common names. A lot of our other organisms have common names. Bees don't, because we just haven't spent the time putting names on it. But if you have a good name, there's actually a mechanism for actually getting that recorded someplace. It depends on whether or not people are going to use it, because common names are not the same thing as scientific. But anyway, these are common bees here in California, and we're looking at bees now, and I say that throughout the state. So this is why I'm showing you this assortment of bees. Here's another group. Once again, these are very common bees. I wish I had a corner I could tell you something, but the upper left corner shows you how perfectly the bee fits into that salvia flower. And look at the deposit of the pollen on the back. Even on the stigma, there it is. There's pollen for you. Pollination really is the act of contamination. I mean, bees don't know what they're doing except to go after the rewards, but in the process, the plants have taken advantage of that need that they have, and they've actually used it, so they get themselves reproducing. A couple other things that are really important here in California, and I'd love to argue with nursery people and gardeners about this. That is, most native bees are solitary, and most of them like to nest in bare soil, or soil that has a very light leaflet. So this means automatically, if you're a big, heavy-duty mulcher, you're really not creating much habitat in your garden or wherever you live, or bees. because they can't get through that thick mulch. 30% of these are cavity nesters, that is, they go for cavities that are already existing. That's the reason why we can use those bee boards and bee little houses and so forth. They actually, we put those houses out and they come to them. I mean, you're taking advantage of the bee leaders. Now, it was already talked about in terms of the next slide. I had a point, I could really point this out to you, but this is what happens when you trap nest, or when you actually capture a bee and you watch it for a while. It makes a nest. Look at all these bees, they're all tucked. Let's see, you said I should go for F5? No. Okay. Okay, we put a bunch of sticks out that were drilled. This is Douglas fir. We put them out. They got filled up with a leaf cutter, and that little line of green cells or green tissue that you see, those are all leaves. There's about 7 cells in there. If you take a look, and you take one of those cells out, go to the upper left corner, and you can see what it looks like when you unravel some of the leaves. And if you take the lid off, you can see that you have a pollen mass there, in yellow, and you can see a larva of a bee, and that's feeding on it. That's what leaf cutter bees do. And you can see this in your own garden if you want to take the time to look at that. Those sticks there, they'll tell you what's filled, and you can actually take advantage of a lot of bees in your garden if you have these things out. You have to be careful the way you actually manage these trap nests, though, because you do need to clean them out once in a while. There's all kinds of things come in there besides bees. They have to be aware of that. Here's another thing that's really interesting. We like to talk about, Neil talked about this too, and that is bees have a list. And their list is they need pollen, nectar, and sex. And we like to talk about that because, first of all, some people say, well, what's the difference between a bee and a wasp? Do you know? What is a wasp do? What's the lifestyle of a wasp?
Paper.
It's a predator. It eats meat. All bees are vegetarians. Great difference right away when you talk to people about that. So there's no such thing as a meat bee. A meat bee is a wasp. And just to give you an example, yes? Oh, you have a point? Ooh, thank you very much. I appreciate that very much. I forgot mine. Thanks a lot. Appreciate that. All right. Oh, yeah, look at that. Well, only females sting. You can hold male bees. You don't know why? Only females sting. Because the male what? Yes, the ovipositor of the female has been modified such that it can lay eggs. It can also use the same canal down to which it produces venom. It's a good protective device against the nesting females. So you can hold bees like this. This is called a teddy bear bee. You all seen this one? How many of you seen this bee? I know some of you must have. And you can grab these things. You can grab these bees. And you can hold them. And just don't give it a name, but you can hold these bees, and you can show kids, and you can use it to demonstrate some of the fine things that you can look at with a live bee. This bee will not bite you, it won't sting you, and it's a great for environmental education. Now the bees have three major types of pollen collections. Some that carry them on the legs, like this one. Some on the abdomen, like this one right here, leaf cutter bee. And this one carries it in the modified portion of the digestive system, and it regurgitates the pollen when it goes back to the nest. So there's 3 different ways to give you some idea of the lifestyles of these kinds of bees. This is just a life history. I'm not going to spend much time on this because I want to get on to some of the major events here. But it goes through a cycle like this. Adult, based on pollen loaf. The larva develops, comes out as a pupae, the following year comes out as an adult. Now, what does this mean? Because people say, well, gee, I'll see the bees certain times of the year, then I don't see them another time of the year. So this is what it looks like. Here's a male and female come out of the same genus species, and they mate, They go down, the female goes down, lays eggs. The eggs develop into larvae, then it goes through a long time period, then it goes into a pupal stage, eventually adult, comes around the following year, and it emerges. It's only the adults at that time of the year. So this tells you something about the seasonality. These bees have a seasonality that's tuned in with the native plant materials of the state of California. So when you see seasonality or hear somebody talk about seasonality, you're really talking about a historical picture here of the bees and their relationship to native plants of California. This is really an interesting and actually very valuable thing to keep in mind. The reason for that is the following. If you look at this theoretical display of pollen, nectar, pollen, nectar, pollen, nectar throughout the entire season, you'll notice that you have 4 seasons. We can make that. No, I guess that's it. And what you have then is you have social bees that are out for most of the year. There's an email coming through. Okay, that's all right. So then what you have are groups of bees. These groups of bees come out at this time of the year, and then they kind of disappear. And you don't notice that until you're looking like we do. And then you have another group that comes out, another group, another group. There overlaps. But you have different seasons of the year for bees and plants. Plants have seasons, everybody knows that. But you may not know that groups of bees have different seasons as well. And this is a historical picture based upon the relationship of these bees, these native bees, to the native flora of California. It's a really interesting piece of information that you can use, and you can take this kind of information and you can create bee gardens. And you can predict what's going to be coming to your gardens. And that's why I call this a selective process where the bees and the flowers get together. I'm going to talk some more about that. I'm going to show you how we use this information in agriculture. We've already talked about this. I'm not going to go into it anymore. Colony collapse disorder does not occur with native bees. They have their own set of problems, as Neil mentioned. They have predators, parasites. They have all sorts of problems. I'm going to talk to you a little bit about the work that we've been doing at Berkeley over the years. It started in 2003. And we have right now in Berkeley, where we've been working, we have about 88 species of bees in Berkeley. And about 60 of these came to the Oxford tract, which is an agricultural tract in Berkeley. And we want to, at that tract, we want to look at bee-flower relationships. We monitor the bees. We evaluate optimal plant management methods. In other words, should we do some pruning? Should we do some deadheading? Should we use fertilizer? Should we use water? We look at those kinds of issues. And then we use these evaluations for habitat gardens. And that's where I'm leading up to with regard to agriculture. We started out in 2003 in July, and I asked my assistant Mary to go out there, stand right here, and after she did that, we went over here and picked up the plants, which were Helianthus annuus, sunflowers, along with Cosmos. We carried the plants into the field, and native bees followed us into the field. And this is really humorous, but at the same time, it's a reality. Bees are always looking for new resources. And you can take advantage of that. As soon as you set up a pollinator garden in your neighborhood, community, or in your front yard, in most of the cities of California, you will find the bees come in very quickly. This is what it looked like in 2005. Beginning to diversify. We just added plants that we knew that bees liked in the Berkeley, Albany area. And then in 2008, we divided the garden up into this being all native plants, and in the back, non-natives, because we knew people liked non-natives as well, and the bees liked them. So here's some things that we have learned. That is, bees like certain kinds of families. They like the individuals of certain families and not others. They love Asteraceae, and they love the main family, Lamiaceae. Boraginaceae is becoming a bigger, important family. We published all this, so you can get this on our website. The other thing I want to call your attention is don't miss out on the opportunity to watch bees. Some people who have gardens, they stand back and they look, and Kate Fry knows this. They stand back and they look and say, oh, this beautiful landscape. You've got these plants and these colors, and you've got a trail, and you've got water, and you've got rocks, and you've got, there's blue jays too. But in fact, you should get up close to those flowers and take a look at what's going on, because that's what the bees are doing. And you can learn something about bees if you do that. For example, here's a bee that is pulling pollen off the anthers, and she's packing it on her belly here. This is a leafcutter bee. She's not interested in what's down here. This one is, though. Okay, it's the same flower. It's Selective campanillaria. And she's going down into the flower. Actually, this is a male. So, take a look. Take the time to look, and you'll be surprised what goes on in your garden. Well, I can pay you to know that. So what I want to tell you about, this is very interesting. This is something now that gets to the selective business, and that is bees like to forage in native plants. And we did a sample of 1,000 plants types in Berkeley. 950 of these were non-natives. 50 were natives. And this will tell you exactly what bees like to do. And of these 50, 80% of those had bees at measurable levels, so we could actually record the visitation. In the case of the non-natives, only 8% had visitation. However, 8% of 950 is still a lot of flowers. Things like cosmos, things like gaillardias, things like this. Wow.
Does he have to be connected to the network?
No, it's my computer that is trying to connect.
You can't turn the airport off and the wireless off?
Well, I'll tell you a little bit more. Here we go. So we know, for example, if you deadhead flowers and you prune, you get a lot of responses. In fact, how many of you have echi in your yard? Echi is a great plant. Did you know that those big, long, beautiful blossoms that come out, they produce one kind of flower? And if you cut them off, just at the end of the flowering, you get another whole set of flowers. Did you all know that? They don't go vertical, they go horizontal. How about Selective campanillaria? This is what I'm going to talk about. If you cut that one off halfway, during the middle of its flowering, when you know it's being on the decline, you'll get another whole cluster of flowers coming out. Anyway, we experiment with things like that. We're bee-centric, so we're looking always at ways in which we can enhance the flowering and produce the rewards from the bees. But we also can stagger annuals. You can plant them at different times, and then you can get a sequence of pollen and nectar. Here's something I want to show you. This is where we go in California, Redding, all the way down to here. We're on the road a lot. The guy at my service center at Ford, he says, how is it you put 20,000 miles on your car? He said, well, that's a long story. But we survey 10 cities right now, about 40 gardens throughout the state. And these are various types of gardens that we work with. And we have new ones planned for Chico, Placerville, Visalia, and Sonoma. So this is what some of these go. Oh yeah, by the way, I want to tell you also there's a few places in California where bees don't like to go because people don't garden the same way. Now I've been told by gardeners and nursery people that every city's got a slightly different kind of nursery mentality or gardening mentality. Didn't know that. The worst city in California for bees is San Diego. Well, they don't plant the right plants. I've been down there, my students have been there, we surveyed everything. There's just no good plants except for lawn and a few occasional cosmos, and that's about it. There are other places. Paso Robles is no good. There's another place that you'll be surprised. It's Monterey Carmel and Pacific Grove. If you look at the plants, they're the wrong kind of plants. They have gardeners there that put in things like agapanthus and a few other things that bees don't care for. In fact, that moved us over to Santa Cruz. Santa Cruz is the most diverse plant habitat in the state. And I always ask Santa Cruz people, I said, why is this? Why is there so much plant diversity here? And they always tell me, well, we have a lot of diversity of people here too. So I'm going to show you some of these gardens and dazzle you with some numbers here. This is a garden in Ukiah, about 30 feet by 30 feet. We monitored it for 3 years, It had 55 different plant types that bees like. We've got 68 species of bees coming into this garden. We did add a few plants here, though, which helped the process. But the point is, this was a really great place. And here's another place in Sacramento at the what do they call it? The Pioneer Cemetery in Tower District. We have about 75 bee species coming out of this place. This is a really great place to work. Nobody bothers you here at all. Here's a garden that we worked in San Luis Obispo. We published a paper on this. The people there wanted to have bee plants intermixed with vegetable plants. And we started out, we had 5 bees when we first started. After 3 years, the plants interspersed here and there, we got 40 species of bees. So you can do things even with existing gardens. So we now have a count of about 300 bee species, and still counting, on about 400 different plant types throughout the state. And we put this into an access database so we can pull up numbers anytime we want and where they come from and so forth. I'm going to show you some numbers here about the kinds of numbers you have in the state of California. In Kaya, we already pulled up 95 species. In here, we think it was about 110. 82, 88, 99 San Luis Obispo, 112 here in Descanso Gardens in Southern California. Every time we go there, we don't spend much time there, but we just always get a few new species of bees. So some of these gardens, I mean, it's amazing what you can pull in when you start the work. We also do frequency counts, so we know exactly which bees come into the plant, and we do special visitation counts, and we also know what abundance level, so we can tell you which bees prefer which plants. Again, this is getting to the selectivity thing, which I'm going to show you how we apply that shortly. We actually are about 8,000 or 9,000 frequency counts now that we've done, and we do these for 3-minute intervals, and this is a couple of my students doing this. I can tell you more about it if there's time. But I also want to show you. There's a chair if you want. Okay. That's okay, yeah. Well, I'll tell you something interesting now. So, one of the things that's really interesting about plants and about selectivity is that there are certain plants in certain parts of the world that bees don't like. They don't like plants from New Zealand, Australia, North and South Africa, and they don't like plants from Central America and South America. I'll tell you more about that in a second. So, yeah, the next one, quickly. This thing, so. Okay, so here's an example. Here's a really good example. If you go to San Luis Obispo, there's a botanic garden called the Leaning Tree Arboretum. It's wonderful. Here's all these South African plants in full flower. No bees over here. Once in a while, a honeybee gets over there and gets lost, I think. Right there across the glade of the lawn, here's all the native plants, and here's where all the native bees are. Giving you a good example. Santa Cruz is the same way. You've got Australian plants there. But there's hardly any bees going to the Australian plants. They're all in the native section. So this is what we did. We took a look at where these plants come from. And we selected all the plants that we knew were attractive, that were non-native, 87 of them. And we said, okay, well, 24% North America, Mediterranean 19%, and it goes all the way down here. Then you get over here to really rare things, Central South America, North Africa, South Africa. Hardly anything comes from these places. They just don't go. But yet, the flora and the fauna of those countries, they're just huge relationships between bees and flowers. But California bees don't like those flowers. Now, the other thing, too, you might wonder, California oranges, this is where you get hybrids and things just show up in gardens, and next thing you know, they're planting them and selling them. So, this is the breakdown of the non-native plants that are attractive. Here's another aspect of this program I want to show you. Bees are very predictable in where they go, especially in urban environments. This doesn't apply to wild. Here's a California poppy. Yellow-faced bumblebee likes this plant a lot. Honeybees like it, and 3 species of sweat bees are in the family Halictidae. That's what you're going to find throughout the state of California. So that's how selective they can be. Let's get over here to wisteria. What comes to wisteria? You all know that one, right?
Carpenter bees.
Carpenter bees, yeah. Why do you think that is? Well, first of all, the other bees, don't have a chance in this flower. It's so strong. The petals are so strong. It takes a very powerful bee to get into that flower. Honeybees go to it. They go in the side, and they go to this side, and they can't get into it the way this guy does. Okay? So it's very selective. So if you're going to plant wisteria, you know what you're going to get. If you plant Selective tanacetifolia, which is one of the most wonderful bee plants, you know what you're going to get. You're going to get a wide diversity of bees coming to it. Yes? Can we talk about that a little later? Yes. I like carpenter bees anyway. I don't mind if they drill a little bit. I've never seen a building come down, by the way. Okay, so this is a beautiful plant. Selective tanacetifolia or Tansy. How many of you ever looked closely at this flower? This is actually a series of flowers. Tansy. That's one of the common names. Anybody ever looked at the pollen of this plant? No. It's purple. You'll see a bee coming with little purple bags on its legs. With regard to that, there are other things that you ought to know about. How many of you ever grow coriander? Have you seen coriander? Ever seen the bees fly away from coriander? Pink pollen. Pink pollen. They fly away with little bags of pink. Okay, so this is the plant I was telling you about earlier, that if you cut this plant off when it's just about finished its flowering, or maybe 2/3 of the way through flowering, it'll produce another whole volume of flowers. Big part? But we actually give all our plants extra water, even the natives, yes. Because we're bee-centric, so we want to see the plants having different resources. Here's just some more work that we've done with nectar monitoring. People ask us, well, what about the nectar? So we've actually monitored nectar with microcapillary tubes to find out more about it. This is very early work, but some of the patterns that we're getting are like this. Some just quit after a point, some actually drop down gradually, and some actually have a second peak. And we've seen that in a number of cases, a double peak. We've seen this also in our work in the tropics as well. So this is just some more double peaking. And I'll show you where we also work in the tropics, where we get the same kinds of results. This is our Oxford tract. This is University of California, is over here someplace. And then this is the Oxford tract garden, Oxford Street. This is Virginia. And I'm going to take you on a little trip, quick like, to Costa Rica, where we do a lot of work. This is Taboia rosea in the Bignoniaceae, a magnet for bees in the tropics. You take that plant up to Santa Barbara or someplace in California, no bees. Honeybees will come in occasionally to look at it. But this is an example of the bees there are associated and have evolved with those plants there. This is a native in Costa Rica and part of Central America as well. If you bring it to California where you think it's a magnet, like Santa Barbara, you can grow anything in Santa Barbara. If you ever lived there, it's a great place. But that's a great example. Here's another one. This is the Media Peruviana. And nothing comes to this flower in California. But in Costa Rica, orchid bees. And all sorts of other bees come into this plant. Take a look at this. This is a really cool shot. This is an orchid bee. Here's this mouth part right here. And you're only seeing 2/3 of it. The mouth part goes down into here. These bees are long-tongued bees, clearly. Here's another one. This one is very common in the tropics. Pulls in lots and lots of bees. This is Tacoma stans in the Bignoniaceae. And if you plant this thing in Southern California, for example, in Santa Barbara, you'll get honeybees coming to it, and that's it. No native bee. I've never seen a native bee on this plant. Also, if you do one other thing, too, if you take some of our native plants and bring them to Costa Rica, like this one, this is in California now. This plant, this is Helianthus, which is a very good attractor for bees. The bees don't come to it in Costa Rica. So there's some real relationships here between the evolutionary relationships that have been well established. We'll pass on this one. This one, the same thing, hardly anything comes to it. So we've transitioned now with our knowledge to Brentwood, the farms in Brentwood, and we were invited there by the USDA and also by Farmer Al at Frog Hollow Farm. Some of you may know the name. And we went there because he has a very casual attitude towards his orchard. And they asked us to come there and bring our urban bee knowledge to the orchards of Berkeley. So we started out, this is what I like a lot, because there's a lot of plants in here that bees like, a lot of weedy things. And Farmer Al's pretty weedy when it comes to this sort of stuff. We were there yesterday. This is what his orchard looks like right now. Peaches. This is Mount Diablo here. We're east of Mount Diablo. So, we started in 2010, and now the project has grown to 8 farms. 4 of these farms we add native bee plants to, and nesting habitats, and 4 of the farms service controls. We had planned to go to 10 farms, but there's just too many bees. We can't actually deal with it, so we're going to stick with 8. This is what we've done. This is Facelia tanacetifolia. Farmer Al said, yes, Farmer Al. He said, go ahead and plant between the rows. This is Facelia tanacetifolia, full of bees. And it reseeds itself. And since he's a weedy guy, he doesn't do any spraying. He's organic. So these things come back on their own. Here's poppies. Didn't have any poppies. Not a single poppy in Brentwood on those farms. I said, how could this be? This is California. So we went out with stews and we just threw all the seeds in. And we got a lot of flowers. And we also plant at the end of the fields. This is all Salvia brandicii, combination of Salvia brandicii and Salvia mellifera for nectar sources. And this is Farmer Al examining the bees and the plants of this particular. You know what this plant is? Not Budley. Somebody knows. Come on. Vitex. If you want a great plant for bees, both honeybees as well as native bees, Vitex. That's a good one. Okay, that's Frog Hollow. So we moved over here to Dwelly Farm, which is nearby, and we focused our attention on the berries, because he has a good berry crop, and we can actually deal with berries. And so we started planting these things called hedgerows. We brought all these ornamental plants in, and the bees just come pouring into these plants, and they also go to the berry flowers as well. And here's a Facelia. This is Facelia secretaria, beautiful flowering plant, flowers for months, and just pulls bees right in. Here's another farm we work on. Same thing, Eno's farm. And we started with one hedgerow. The farmer liked it so much. He said, well, you can have this strip too. And then he said, you can have another one over here. Once these farmers get used to you and if you spend enough time with them, you'll find that they keep offering you more and more. In fact, that's actually become a problem because our control farmers say, well, these guys are getting bees and, you haven't given us anything. And we tell them, you can't have anything by us telling you, because if you do that, you'll screw up our study. So we said, well, you go ahead and plant what you want, but just don't tell us. So we've established baseline diversity and abundance, much along the lines of what Neil talked about earlier. We know our sample periods. We know exactly how to sample, how much to sample, because there's so many bees coming into our sampling traps and into our sampling collections that we just have to limit it. So we know the methods, and we can identify the bee groups moving from the plants to the crops. So this is all very nice and well. And just to give you an idea, we now have about 58 different plant types. So these are all plants that we know something about from the urban environment. And then we continue to learn more about them as we put them into agricultural fields. For example, some of the plants we use, we know now are just so prone to attract gophers. We just stopped using them because gophers are a big deal, especially in an organic farm. They're just out there. I mean, they're just so. How many of you know? Have you ever looked at the California bear fly? You ever looked at the bear fly? Ever seen the bear sit on top? The bear's gone now. We went it out. It's a green patch, right? You ever see those little brown spots, those little brown clumps? Guess what those are? Gophers. Gophers and ground squirrels. We're the historians here.
That's what did the Russians do.
That,
Up at Fort Ross.
okay, there it is. Another story. Okay, so anyway, let me just give you some results here. We have about, already, this number is low right now. We're up to about 50 species of bees coming into some of these farms. And some of these farms are conventional as well. So it's not only happening just in the organics, it's actually happening in the conventional farms as well. Bees are passing through the area. We have some natural areas nearby, within a mile or two, and the bees are coming down in. But they also are nesting in the orchards and nesting in these areas where they can find a place that's good. So we have two species of bumblebees. We have collectids, we have osmia, these are the leafcutter bees, and we have these larger bees here as well. Like this one, here's a leafcutter bee, and of course a beautiful bombus. So the bees are coming into these areas, and where do they come from? Let me show you. We find them in this area, nesting. We find them in the orchards themselves, and of course look at these hills nearby. Neil talked about that as well. We have the same situation. Bees are always moving. Why do you think the bees move?
They're busy.
Tell me something about California native plants. What do you know about California native, especially annuals? They're seasonal. What does that mean?
They follow the crop.
They're changing all the time. If you're a smart bee, you have to be moving all the time, looking for new sources, because the flowering of native plants comes and goes. So we still have this historical pattern of bees searching. And you can take advantage of that behavior when you have your bee garden. Okay, so I want to make some additional remarks here. The beekeepers in these areas now have moved all their bee boxes over where we have our hedgerows. There's no surprise there. They're not fools. But the interesting thing is that we realize now that we have to learn how to make partners with farmers. It is not so much a matter of we can develop research in a classic way, give it to the extension people or go out and do it. We have to actually learn to partner with farmers. And these partnerships are really important because we have to figure out how our recommendations are going to be integrated into their farm practices. We have to know about farm practices. We also have to know about their farming business. We have to know something about their economics. We have to know something about the trends that they follow. So we have to know characteristics of these farmers. So we've actually formed partnerships rather than just simply information transfer kind of things. So we're out there at least once a week in these farms, working with farmers. And here's Farmer Al. He tells us, he says, I love these bees. I love what you guys do. He says, but I'll never be able to learn the names of all these little tiny bees. So we're working with special ways in which we can transfer some knowledge to their workers. And the workers are all Spanish speaking, so fortunately, two of us are Spanish speaking too. So there's lots of challenges that are social. Neil talked about this in his talk, so we're into that sort of thing as well. But I also want to show you that, so we need good farm cooperators. We've already developed baseline data. We're interested in bee habitat in the farms. We know we can create that kind of habitat. And the more we talk to farmers, the more habitat they give us, or the more spaces they give us. He'll take us around like Farmer Al gets in his golf cart, and he'll take you all through the areas. You can have that. You can have that. And what I'm saying is, we just haven't got the time to plant in these areas. But we've got all these areas set aside now that we go. The other farmers are doing the same thing. But once you get started, it's pretty cool. Here's what we really need to do with our work and our knowledge. We need to design bee floral habitat synchronized with the flowering of the crop plants. And Neil talked about that, and we're into that as well. So each farm is different. Each farm in Brentwood is very different. Farmer Al is all stone fruits. He has about 100 different varieties of stone fruits, by the way. Some of these guys have all row crops. Some are a combination of stone fruits and row crops. So each farm we have to design something different for. So this is where the challenge for us is very interesting. Let me see, I think I have a conclusion. Oh, yes. So anyway, you can read the conclusions. This is basically what I've been saying. And we think our work probably will take another 8 to 9 years for it to really to come to fruition. And if we continue to have problems with colony collapse disorder, we're looking at native bees supplementing honeybees, not replacing them, although they probably could in some cases, but we think we like the idea of supplementation. Okay, so I'm going to throw something at you now that somebody might not like, but anyway, here it comes. There's a bee calendar out, and this is one of the bees from last year, and this happens to be Miss July. Our website, right here, helpabee.org. Thanks very much. Very.
Start, we got to kind of go around the mic too, people want to be heard.
I just wanted to know what plants you specifically started avoiding for their food for
We are having problems with large leaf ceanothus, especially ceanothus rayhartman. We didn't think the gophers would go after it, but they just terrorized our plants. So now we're using these gopher bags. I don't know if you've seen these anti-gopher bags, you know, the ones that they're wire, they're mesh wire. We tie them up so we keep away from there. They also like some of the, let's see, I'm thinking about some of the plants that they like also. They're starting to disappear, so we actually have to replace them. There's about 3 or 4 species of plants. I'll think of it as I go on. But we are always watching to see which ones are surviving. And we're also watching to see which ones can make it in Berkeley. Echium, for example, doesn't do very well in really cold pockets, but it'll do well in warm areas. So we're looking at echium as being something that you can't plant over here, but you can plant it over here, even on the same farm. Yes?
Do you have anybody studying any other insect species that are attracted to these birds, such as beneficial insects?
Not yet. We have all we can do is keep track of the bees. Yeah, we have hundreds and hundreds of bees we have to process.
So have you noticed?
Oh yeah. Oh sure. When you create habitat, you're going to bring other things in, birds and so forth. And we chase birds away, by the way. Well, what do birds do with bees? They eat them. Blue jays and mockingbirds. I'm always throwing stuff at them.
But do the bees?
Redwood tree.
The redwood trees, the hummingbirds go to it and seem like they're sucking on it.
Well, we haven't planted redwood trees. Are you talking about redwood trees?
We have redwood trees in our yard,
Yeah.
and I'm just curious because the hummingbird loves it.
Oh,
I'm just wondering about bees.
I don't know.
Really? Oh, my.
Well, if you don't understand something about hummingbirds, let me explain here. First of all, hummingbirds eat a lot of nectar, but they also need protein, so they go after the spiders and insects. But I wish they would do that. They do? Oh, well, that's good. I didn't know that. Yes. Yes, they will. And they'll also, some of the species will actually nest in bird boxes. Bombus melanopigus will nest there, and the yellow-faced bumblebee will not. It goes into the ground. Yes?
If you go to your website, can you get a list of the plants that certain native species?
Oh, yes, it's all there.
It's all there.
It's all there. We worked 13 years to put that list together.
Great.
And we just updated it. We update it every year.
This is your website?
Yes, helpabee.org. Yes.
I'd love to know just a little more about mentioning about the mulch aspect and
Yeah.
bees that nest in the ground, which is something I've heard you talk about. And I've heard some other people talk about the other side and trying to figure out for my property what I want to do. Like, my first question is when you make like the bee condos with the holes in the
Yeah.
wood, that substitutes for the ground nesting?
No, those are cavity
Different
nesters.
species.
There's a totally different group of bees. There's cavity nesters and there's ground nesters. We just don't like to cover up the ground with mulch. And it's pretty unnatural, especially if you have eucalyptus mulch. You know, it doesn't even belong in this continent. But if it gets thick, they can't get through it. But they can get through very light leaf layer. So we tell people if you have to use mulch around something because you want to protect it from moisture or whatever, just use it around the plants that you're particularly interested in. Mulch also does other things that most people don't think about. It attracts termites, it attracts piddlebugs, and it attracts ants. And if you talk to people who have to deal with mulch, that is long term, they'll tell you stories about, you know, mulch isn't the best possible thing to be using, even though everybody says mulch it. Not true. Okay, yes.
For the cavity nesters, is there a specific diameter that you would
We would recommend 3/16, 1/4, and 5/16. Those are the 3 ones for California. If you go south of the border, you want to get to bigger hole diameters. But California, 3/16, 1/4, 5/16. And you can drill these into boards, 4x4s, for example, or you can take we do with sticks, and then you can open the sticks. And you can buy commercial. There's some commercial products back in the tables back there that you can see it. And we use those too. But you have to be careful with these commercial bundles of these like straws, because you have to clean them out. Because at certain times of the year, earwigs go in there, you'll get wasps in there, you'll get ants in there. So you have to be thinking, and parasites go in there. So we recommend after 2 years, you clean them out and start over. In Costa Rica, where we work, we get crickets, we get frogs coming into those holes. You look down at some of the half-inch ones, and you see a frog looking at you. We use them, yes.
Any relationship with earth forms and habitat?
We've never looked at that relationship. We still have a lot, there's many things we can still look at, yes. Pest control, like what?
Like, bugs that are bad for the plant.
We don't use pesticides. No, they kill bees.
You don't bring in ladybugs or anything?
Well, we do, they come in naturally. The other thing I can tell you about pest control is, if you have a plant that's persistently bad, think about replacing it with something else. Anything else? Yes?
Do all of these native plants that attract bees necessitate full sun, or are there shade?
We have shade lovers too, but for the most part, it's about 95% sun lovers. Yeah.
On my willow tree, year after year, in the spring, bees, all kinds of native bees, honeybees, flies,
They're after the pollen. They're after the male catkins. They're after taking pollen. Yeah. Same thing with oak trees. They'll go in oak trees and take out the pollen there too. And sometimes even grass. The bees will collect pollen. So they don't confine themselves to just what they should, what the textbooks say. Yeah.
how many species are on one willow tree?
Yeah. Bees do a lot of things that aren't in the textbook. Like for example, some of these bees are actually robbers. They illegally forage for nectar. They poke a hole in the base of the flower. You've seen the carpenter bees do that. And then honeybees come along and they look for those holes. And then some of the bumblebees actually learn to do that as well. And in the tropics, there's a whole series of bees called stingless bees. They actually chew holes at the base of the sepals, and they actually go in after the nectar. They'll spend half the day chewing until they get to that nectar. So there's a lot of things we haven't reported yet in the literature, but these bees are, they're after that nectar. Yeah.
The increase in, like, the increase when you add native bees to the orchard,
Yeah.
and pull up that where the native bees is creating some of the chemical, functional facilities.
But we haven't looked at that. I mean, Neil's been doing that kind of work, and we could eventually, if we talk to Neil, we might be able to do some of that. But our goal really is to get as much habitat created as possible. And we say that, we don't have a goal in terms of how much, because native bees vary in their population through time. So they're not always present in the same numbers for each of the species. So we have to make sure we get a whole bunch of them together. So we're looking at as much native habitat as possible, and also what the farmer will give us. So those limitations are really, clearly in our focus. Let me see who hasn't asked it. Yes.
I live in an area of vicious pine trees along the coast.
Yeah.
And I've never seen a big area of forest that I've never seen bees collecting.
Well, it's a wind-pollinated plant to begin with, so it's a wind-pollinated plant. So you wouldn't see it. Same thing with, like Neil was saying, or somebody said it. If the bees disappear, well, there's an awful lot. It would eat a lot of tortillas and bread with corn and wheat. So that's wind pollinated. Yes.
Some of the plant species taken from our area.
Yeah.
What about the species themselves?
Well, it's interesting. After you maybe do we have microphones?
Yeah.
So, have you observed any non-native invasive bee species coming in and being aggressive?
Yeah, we have. There's a number of them that do that, but there's an awful lot of native bees that are just as good at repellent, for example. There's a thing called amphibian manichatum, which came in a few years ago in California, and it buzzes around, forms territories, chases other bees, but other bees chase it too. And in the tropics, for example, where I work with, there's African honeybees, used to be really numerous. The native bees are just so overwhelming, they just knock the crap out of these honeybees. They just knock them on flowers, they chase them. We just consider those bees to be part of the mix. You know, one of the boys that comes and the girls comes into the flower. That's just one of the bees. There's nothing special about honeybees with regard to a mix of bees on the plants that we work with yet, that we work with. But again, Neil's group has found that some of these native bees can actually improve the efficiency of the honeybees. So we have to look at that. But I wanted to stress to you that when you add honeybees to the mix, you're just adding one more bee to the mix. You really are. And you should watch these things. I mean, you can learn a lot, and you can answer questions like that by watching these bees. They'll tell you a lot if you watch. Yes?
I have a lot of yellow jackets in my area, and they're very warm that I have trouble with
Mm-hmm.
I'm wondering whether the native bees have similar problems with yellow jackets coming out after their nest or the larvae.
They do in the eastern United States. There's hornets that actually come after honeybees, for example. And there's also ants that we have problems with some of the native bees that they nest in the ground here. We haven't studied that very well, though. I think I'm out of time, really.
We are officially out of time. With that, thank you very much.